Hey guys, again Mujahid here. So consider this video will be as a part 2, so which I have been upload before. This video will be the part 1. So in them I explained about the front end interface and how interaction goes with the contract, and also explained the advanced flowchart, and I have given the Gitbook link as well to understand the better flow. And also explained about the idea, what is my idea about the NounShards, a fully on-chain product for nouns. So in this video I'm going to explain about the contracts, like what types of contracts we have and what types of functions the contracts hold, and those all. I'm going to explain about the schema as well, and I will show the sample attestation which I have been done here. Okay, while going to the video, so here we're going to see that noun IDs. So here we can see the my noun tokens which have been deployed for myself, because as of now I don't own any noun to test in real life. So these token IDs which refers for testing only, so which have been taken images for the from the nouns DAO APIs. So I fetch the images into my Next.js applications to showcase, to view better for the user experience. So these are the my tokens, so I can mint, I can burn, so it's up to me. So while going to the another contract, which is a tokenized contract, tokenized noun contracts, which means, so as in the discussed in the previous video, that so we are going to issue the T nouns, right? So here it handles all the T nouns. So here we can see the already some tokens are deposited here. So here we can see one. So these tokens indicates the ERC721 tokens and are coming from my nouns tokens. So here you can see the 10. So up to now I have been tested with the 10 noun tokens. So these 10 noun tokens are have a and timestamp for up to 1 year. So it's like next year, this time 2025. So user can withdraw the nouns from there. So here we have it holds the 10 noun tokens. So actually this contract is related to the T noun, so which gives the reference T noun to the actual noun owner. So these T nouns can be tradable in the future, which I have been discussing in the previous video. Can be tradable in the future exchanges, or can be traded with the P2P trading as well. So, and coming to our fractional nouns, so it is like an ERC1155 contracts. In the tokenized T nouns are the ERC721 contracts. Here I have taken the ERC1155 because of to create some multiple non-fungible tokens, so which likes it's creates like a fractional nouns. So here we can also interact here. So in the previous video you have seen that we tokenized the 8 here. So let's see who is the owner of for the token ID 8. So for the whole three contracts we are taking the same token ID, same unified token IDs. Okay, so we're taking the same unified token IDs. You can check here. So who is the owner only? Yes, here owner for the token ID 8. It's obviously me, 0x1, so which I have seen in the previous video. This is my user address here, you can see. So in them you can see this. So who is the owner for here noun ID? Let's go and see this 8. So it's obviously my tokenized noun contract. So 0x80, you can see here 0x80. Yes, and also yes, we can go through this navigator. So I have provided the links as well here in the repo. So in the readme sessions I have defined all the links related to the addresses and the schemas as well. So please go through it and test if you want to. Yeah, coming to the fractional nouns address. So here the main drawback is we don't have any owner of functions as of now, so we can check with the balances here. So okay, let's take this address. So I have actually challenging here that, so I need to fetch the owner of the token ID. So for this I have used the enable set, so which have been explained in the flowchart here and also submitted in the Defolio. You can see there as well. So how I achieved this thing, like how to get the owners of the fractional nouns. So now you can see I'm going to check the token ID. The unified token ID will be the same, so it gives the balances of 1 because we have minted here, right? Yes, it gives the 1. If it's 0 means it is like one of the one of the bug we can say. So it actually once it gives actually gives 1, so user can also buy another as well. So here I'm not going to with the right contracts because it's take a lot of time. So based on without this I'm going to use the remix ID, so which have been actually deployed for the simply use case and to show how interactions works here. Okay, yes, and so apart from these all, so we have from another schema called this, which have been created on base Sepolia. So where user going to attest with this schema only. So in the previous video I have shown this schema, and now I'm going to explain this about it. So here you can see that I am the creator only. So this is the transaction ID. So this is the resolved contracts. You can see the resolved contracts which is similar to the tokenized non contract. So here we see the 0x80d. So this is similar to 0x80d. So it refers to the resolved contract to this schema. So before attesting it, so it need to call our resolved contract. So as of now we can see 10 attestations is fully on-chain because it's a fully on-chain applications. We are going with the on-chain applications only. This is a fully on-chain transactions only. So let's see application. So one of the I want to show one of the attestation here. So this is the attestation which I have done from the front end. In the previous video I have done with the token ID 8. You can see here the token ID 8 is here, and we can see next year will be the end. You can see here it's like 30 2025. It's up to 1 year minimum, so user can also upgrade it as well. In the contract you can interact with the front end as well. So here you can see the data here. So the token ID address, what is the noun address and what is fractional, and which token IDs is attesting on with the schema, and the fractional noun price, the price which have been set here, and the end timestamp, what will be the expiration of this we can say. Yes, this is the raw data we can say. Yep, that's it. This is all from the contracts and schemas and all. So we are not going with the right contracts because it takes a lot of time while interacting with the MetaMask. So we are going with the remix part to test it thoroughly. So here I have deployed on my virtual machines in the remix. So where I have deployed this on contracts, like it's up to 10 will be minted to me. You can check here, total supplies will be the 10, and every the owner will be is me only. You can see the check balance of the here. So balance sorry, owner. So I need to pass that, sir, sorry. Okay, yes, owner. Hang on. Yeah, so I am the owner. So this is the my 0x5b3 OX5b3. Yes, cool. So later I have deployed this. So for this we are using the attestation, right? So for this I have taken some default contract here and taken the noun contract while deploying it. And while coming to the noun, we're taking this address and we're going to taking this address and pasting here and deploying the fractional noun contract. And later we're changing the fractional noun contract address here, like I always actually called here. Okay, then we are going to mint 10 out tokens. So here you're going to might get some little confusion because here we have seen the on attest function, so which is needed to handle from the front end user part. But as of now I'm the user and I'm the owner, so I'm gonna take some test functions. These are for the testing purpose only, so minting and transferring the known from myself to myself only. So it gives the basic idea about the how functionality works towards it. Let me explain these functions as well to understand even better. So I will go to the I will go very fastly, so please understand these all basic things. So these are some custom errors So I have taken some imports here like schema resolvers and ERC720 enable for easy access of the tokens, and ownable contract and reentrance guard, because we are paying with the user deposits, and withdrawals will be need to be seamless and cannot be hackable. And these are some token state variables you can see here. Now details like you have seen the end timestamp divisor, and you can see we're taking the noun contract address and also fraction contract address to seamless interaction between the uh, t noun and f noun. So in the flowchart I have also explained how they are working with. So these two contracts will seamlessly work together, so that's why we need to integrate both as well. And then mapping to the event ID. So it is as of now it is for nothing, so it's for taking a basic example for the testing purposes only. And later we're storing the collected amount here as well for the distributing of funds. So here at minimum done with let me yes, set sets up to 1 year. I mean the expiration will be the 1 year. Let me change it here as well. I have taken 52 weeks somewhere. Yes, I'm gonna take 1 week. Okay, I need to deploy once again. Okay, let me redeploy it, so you can see here as well. Okay. Yes, I'm going to deploy it. So I'm going to deploy it. I'm taking as the same this as a ES contract only for testing only. I have taken this, which is not recommended for production and testing on the as well as and testnet as well. So I am taking this token address and deploying this address. Yeah, going to deploy this as well. Yes, and we need to update this fractional noun in tokenized noun. Yes, here. Yes, we need to update it. And yes, and first of all we need to approve the t noun here as well. So I'm going to approve our t noun contract here for my token ID 0, and I'm going to approve. Yes, it has been approved. And we are going to main t noun tokens. So for the token ID 0, so here we're going with the unified token IDs, right? Which gives the for a seamless user experience, you can say. So I'm going to use it like 1 ETH. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, I'm going to divide it up to 10 parts. Yeah, so I'm going to copy it for the future. Yes, the renouns are being deployed here. So while deploying, it also mints directly f noun here. So you can see the total supply here. So will be 1. You can see the token ID with 0, the unified token ID. If you check with 1 for testing, it will be 0. Yes, it will be 0. Okay, then so here we can anyone can anyone can mint fractional nouns easily. So I have taken V in passing the amount. So actually I want to buy, let's take ether. So I want to buy 3 tokens. The fractional noun, yes, the unified token ID and parts are need to be 3. Yes, here we can see the 3 ETH is deposited here. So these 3 ETH can be withdrawn by only the t noun owner. Let's say we are going with another address where other user comes to try to withdraw it. Where is withdraw? Yes, withdraw. Withdraw for token ID 0, and yes, I have taken this. So he want to withdraw 1 ETH. So because he's not the owner, so it will be invalid address. It reverts with the invalid address. So where we can only be withdrawal by using this address, the transaction will go successful. You can see here the 2 ETH only. Yes, we have the 2 ETH. 1 ETH transfer to here. Anyway, Yeah, so multiple users can buy the fractional nouns from here by depositing there and up to. So let's say if the user wants to, so that a limit is the 10, so actually 3 is deployed. So actually we have the total supply of 4 here now, because one actually deployed to the T-noun owner. So this is user for the community engagement purposes only. I have created this. So let's say if the user want to, it's 12 parts, let's say 8 for the transaction. No, it's not possible. Insufficient parts. We have the insufficient. So first I will check about the parts, then later the payment part. Okay, then you can withdraw, and where user can also withdraw the known ID, because I set to 1 second. So after 1 second he cannot withdraw the known. Invalid input. Okay, sorry, he need to pass the ether which have been discussed. So actually it was a 2, deposit 2, the user need to pass 3, because it's like a lending borrowing application, right? So it's like in sum of interest. It's let's say it's not about the 1 ETH, it's the price of the f now which have been taken. So if he get the 2 ETH, then he need to pay 3 ETH, like this. So I need to pass 3. Actually in the fractional now we have the 2 ETH. Can see here, yes, we have the 2 ETH. User wants to withdraw this. Invalid input amount. So actually the total supply here we have the 4, right? Sorry, we need to pass it the 4, because we actually withdrawed it, right? So we need to pass 4 while doing the withdraw. Yes, the transaction process. The here we get the 4 ETH. The user can withdraw these 2 ETH as well. So before he need to do this when getting the noun. So that's a before withdrawing noun, he need to user need to get the ETH from the f noun contract. So my application can distribute the amount to the users there. So I'm taking the T-node as addresses. So we can use the indexers. In the practical scenario, I'm saying that we can use EAS indexers on base Apolia or base to fetch the token IDs. Actually it is burned actually, so we can get fetch details from the indexer as well. Like the collected amount will be the let's say I want to distribute 3 ETH only. Okay, 3 ETH. Yes, 1 ETH will goes to the our NounShards, and 3 wanna distribute to others. You can see here is incremented. So this is how the flows works, and you can also interact with the read functions here as well. I will share these links as well. Please go through them, test it. I'm very happy if you test these all well. So please note that these contracts need to be audited, but I have been tested and thoroughly tested it, and I have been deployed and verified on base Apolia. But it's need to be, any contract it need to be audited, right? So my contract it need to be audited. So it's become a lengthy video, so please kindly go through my previous video which I have said to go through with this idea and get to know more. Thank you for watching.